All right, welcome to Chapter 10, Section 7, Proving Segment Relationships. I know the screen there has a different chapter number on it. I'm actually reusing this video from IM2, so it had the same couple of problems. The first thing you'll see on your page is the due date. I just don't see it on the teacher preview here. The second thing is the attempts, which we always give unlimited attempts. You can submit this assignment as many times as you would like. This particular assignment has 2 questions on it, so it just depends on the section for how many questions there will be. Grading policy's best score, so whichever attempt is the best one is the one you keep. And partial credits enabled. So if you answer 1 of 2 questions, you get credit for the 1 question. Please remember that once you start your homework, you have to finish it before you can work on anything else. That has to do with submitting. So once I click start here, down in the bottom corner, I will see submit assignment button. You don't see it on my screen, but you'll see it on yours. You need to make sure you always click that submit assignment button. Number 1, stops the system from locking you out of all of your other assignments, just like that statement said. And number 2, it actually makes an effect in the gradebook. Your teacher can see what you've been working on once you click that submit assignment button. Before you click that, it's just kind of frozen. We can't see it. So over here we have explanation, example, and message center. Explanation literally is going to explain or give the solution to this problem. So we're not going to be able to, come back and type it in. We're going to lose our question attempt and have to come back in and try that on another attempt. Example gives us an example of something similar, what we're looking at here. So this will walk us through, and this one is a bit wordy because we have a lot of steps here, so it's kind of walking us through what we're doing. And we might have one that's segments, like the one we have, or we might have one that's angles, like this one, and I'll explain kind of the difference between the two in just a moment. But what we're going to do is the same thing we did on section 2. We have what this is called a statement and reasons column. I forgot to go over this. Message center. You can also message your teacher directly from here, before, so that your teacher knows what to kind of come help you with. So here, let me open this back up. Okay, so now we'll get into this. So we have what's called a statements and reasons column or table. So on the left side here, we have statements, and this is what we're doing. These are the steps of our proof. We're going from one to the next. And the reason here, we literally have to choose, why are we taking this step? What is the reason for it being in this proof? And another big thing that you have to remember about a proof is if it's not in the proof, then it doesn't exist. So you need to make sure that everything gets included in the proof. And I'm going to be a little lazy here and kind of snap a picture of this guy. Let's see, where is it? There it is. So it just makes it a little bit easier for me to look at instead of having to draw it. So if you don't have the drawing, and you wouldn't have this one because, every time we open this, it's a different problem. So you're not necessarily going to have the same one, but I suggest you either do something along these lines so that you can mark on the page, or you just draw it out real quick. It doesn't need to be perfect. It's really just so that we can visualize all the pieces. So when we're reading this, we're going to be given a certain amount of things. So with this one, I'm given AC equals DF. So if I look at this one, AC, I'm actually going to use my line tool here. AC is this piece here. So there's AC, and that equals, and we'll go with pink here, DF. So this other side here, DF. So these 2 pieces equal each other. And that's a given information. We also have that AB, so this smaller piece is equal to this smaller piece here, and I'll leave these in the same colors. So I don't know if we can make these a little bigger so it's a little easier to see this red outside of here. And instead of pink, I'll make it red so that we can see these are equal. The pink and the red didn't mean anything different. So we have these 2 longer statements are equal to each other, and then the 2 yellow segments are equal to each other, right? So we just have a couple of different pieces from the given here that we already know some information about. So that's pretty nice. All right. So when we put these in the proof, the reason we put AC equals DF in the proof, and we can see that it's coming down here, that's going to be the given. We were given this information. And AB and EF, we were also given that information. So when we're doing a proof like this, and they want us to put in the reasons, we can go through and look. Okay, well, I know these were given. I'm going to go find them real quick and write given. Now, a lot of the time, we're going to be putting the pieces in here. They're not going to be doing this for us. This only happens every once in a while. I believe on the next one, we're going to be putting in our own pieces one at a time. So whenever we start with segments, like a whole segment with pieces, or an angle with pieces, because that's also going to happen where we have angles like this, and we have, you know, angle A and angle B, and this is not really, it's usually 1 and 2 instead of letters. But we'll do something along the lines of segment addition, which means I can add 2 pieces of a segment together to get the entire thing, or we'll do angle addition, which means I can add 2 small pieces of an angle together to get the entire thing. So it's kind of like chopping up, you know, if I cut up a piece of paper, I still know how long the piece of paper was, and I can still line them back up and have the same length. Now they're just in pieces. Kind of the same thing with, you know, segments. I can chop these in pieces with these 2 pieces, so I have DE and EF, but if I put them back together, they still equal the same length, DF. And AB and BC, if I put them back together, they equal AC. So it's just pieces of a segment. That's all this means. So it depends on which one. Since we're starting with segments, we're going to do segment addition. If we were starting with angles, like the example, then we would do angle addition. So it just depends on what you're starting with. So with this one, I have AC, and then they're saying it equals AB plus BC. So this is segment addition. We're adding 2 segments together. And this is a property. I know I have these all outlined on the notes pages. They also, if you click on the question mark here, you can see, oh, why didn't I do it? If you click on the question mark, it'll give you somewhat of a example of what it means. It's not the best one. I don't know if I much like that definition. Let's see, if I click on here, do they give me the better definition? I know I had all of these laid out in the notes pages, but they're not looking like some of the best definitions here. So, yeah, I didn't really like the definition there of segment addition property, but it just means if I have 2 pieces of segment, I can add them together. So now they're doing the same thing for DF. So I have the whole thing is equal to DE plus EF. So this is, again, segment addition. I'm adding 2 segments together to get the whole. So if it was 2 angles, it would be angle addition. The second one we already know is given. Now what we need to do is we had AC, and I like to kind of write this out, AC, ooh, that's a really crazy looking pen there. AC equals AB plus BC. And then DF equals D, dang it, DE, I wrote D really funny there, and EF. And one thing they noted, so the given was that AC equals DF, so we know that AC equals DF. And then the very next one, instead of having AC, what they did was they replaced AC with AB. So I know AC is the same as AB plus BC. So they just replaced it. And that equals, instead of DF, which is what they wrote here, DF, that was the given, they wrote this piece. So what we're doing is we're replacing one thing, AC or DF, with something else that I know to be the same. I know them to be equal. And what we call that is substitution. So that's the substitution property, when I change or replace something with another. Then we have the next piece here. We have AB equals EF. So let's go with pink on this one. AB equals EF. So instead of AB, in this statement, what they're doing is they're changing AB to EF. So if we notice that the only thing that changed from 4 to 6 was instead of AB, they changed it to EF, because I know AB equals EF. So step 6 was another use of the substitution property. I'm substituting EF for AB because I know they're equal. So now if I know EF equals BC, or EF plus BC equals DE plus EF, the only thing that I need to figure out is what did they do here? All of a sudden there's a whole lot less terms. They just went to the prove here, what they were trying to prove, which is BC equals DE. Well, if I look at this piece, I have EF plus BC equals DE plus EC, and we need to also, I don't know why my pen is writing so horrible right now. E plus EF. So I'm going to look at this algebraically just for a second, and if I think of this as just numbers, then I want to try to get the EFs together, which means I'm going to subtract EF from one of the two sides. It really doesn't matter which side I subtract it from. And EF minus EF cancels out. So that's why I'm left with just BC equals DE. So we're looking at geometry, you know, the geometric figures. How do these work together? How do the pieces work together? But we're also using algebra to prove our point. So this is definitely algebra when we're doing pieces like this, where I'm going to subtract EF from both sides. So this, we actually want to go in here and find the subtraction. Oh, it's called addition and subtraction properties. They combine the two. So addition and subtraction properties. So I'm going to go ahead and check this. And yay, we're good to go. Okay, so the next one, we're going to have a little bit more going on here. So and we have a whole lot more pieces here, and I know in class I went through all of these. So we have plus sign, minus sign, times, the fraction symbol still, equal sign. Now we have congruent to. Remember, this is the same size and shape. So if we're talking about size and shape, we use this one. If we're talking about actual measurement, we use equals. Parallel lines, perpendicular lines. This is how we show a line segment, because it'll put the line in there for us. This is angle. So this is a figure. This is the measure of an angle. So if we know the specific measure of the angle, we use this one. This one's a triangle figure. We're not using that quite yet. Blank is a right angle. Blank bisects blank. So depending on what we need to put in there as far as a statement or a reason, we may have to use some of these extra tools. And bisect means to cut in half. Right angle means it's a 90-degree angle. Perpendicular bisector means it not only cuts it in half, but it's also perpendicular to it, meaning it's at a 90-degree angle. Midpoint means it's in the middle, right, of a segment usually. That's what we're talking about when we're doing midpoint. So lots and lots of new definitions that we need to make sure that we understand how to use these guys. Because there's definitely a bit more to memorize when we get to the geometry sections here. All right, so we have this figure of two segments crossing each other, and we're going to use the given information to prove, so remember this is where we're trying to get, QR equals RU. And this is the only drawback. In class, I know when I'm doing these with you in class, if you're in my classes with me, is that the notes pages specifically tell you how many steps we're going to be taking. So I know, like when we did number 2 in class, there were specifically 5 steps on the first one, or no, 6 steps on the first one and 5 steps on the second one. Well, I knew that because I went ahead and I solved it so that I could do the notes pages. But if you notice on here, we don't know how many steps there are. So we have to kind of pay attention as we go ahead, because I don't know exactly how many steps to plan on. But I do know my last step will be QR equals RU. That's where I'm going. And I also know what I'm starting with. I'm starting with these two pieces. So I know that QS, so this whole segment here, equals TU, this whole segment here. So each piece equals the other. And I'll do kind of a bright green here. RS, which is this smaller part here, equals this, or not the smaller part, but the larger part of the segment also equals TR, which is the larger segment here. So we have these two pieces equal to each other. So what you can do, and if you notice there's this send to proof, I can click send to proof, send to proof. I don't have to do these in any specific order. And I tend to just do the givens first. So I already have them in the proof. I don't have to worry about them being there. You can also do them strategically like we did on the last one. So we can kind of start with the diagram and say, well, I can use segment addition. These are segments again. And then I can use these other pieces kind of where I need them. But just throwing them in is not going to hurt anything. It just means that they're already there. We already know that they exist. So now what we want to do is show that this segment, oops, I forgot to turn off my line segment here. So we're going to talk about this line segment here. So TU is going to be equal to the entire segment. I have a segment and pieces. I'm going to use segment addition. So TU equals TR plus RU. And this also starts to bring in RU, which we wanted. So we need to relate this in some way back to what we're trying to do here. So the reason for this is segment addition. So I need to scroll down and find segment addition. And I have to validate it. So each time I do something, I have to click validate. As long as it's good, it's going to turn gray and go to the next one. So now I need to do this next segment here. So I'm going to go QS, and that's going to equal QR, which is another piece that we're looking for here, QR plus RS. So we have QR and RS. And again, the reason I'm doing that is segment addition. So now I've thrown both of these pieces in here. Come on. There we go. I don't know what it's doing. I wanted to undo just that circle. Okay, so now what we need to do is try to connect these pieces so that we can start to eliminate something. So I'm going to need to use some kind of substitution here. So if I know that this whole piece equals this whole piece, I also know that the two segments added together equal these two segments added together. So, and I have a little blue and a green, a little blue and a large green, right? So I can see that those two pieces are equal. So that's what I'm going to do. Instead of QS equals TU, I'm going to go QR plus TU, sorry, RU, equals QR plus RS. Yes, okay. So I'm replacing these pieces. So instead of QS, I have QR plus RS, so that's on this side. And then instead of TU, I have, did I do that wrong? TR, I wrote that wrong. TR and RU. So I'm just substituting. So let's go down and click substitution. So I'm substituting these together. So far so good. If it doesn't like the step, it's going to kick it back at me and go, nope, not yet. And one thing we actually talked about in getting ready for doing these types of things is we were talking about getting dressed in the morning. And how do we get dressed? If we had, undergarments, socks, shoes, a jacket, a shirt, and pants, is there a specific way we have to get dressed? Or can we get dressed however we want? And the answer is there are specific things that need to happen first. If you put your shoes on before your socks, then you're not going to be able to get your socks on. Or if you put your jacket on before your t-shirt, you're going to have trouble, the t-shirt doesn't go on over the jacket, But if I put my socks and my undergarments on at the same, whichever order I feel like it, that's not going to hurt anything. Or if I put my shirt on before my socks, that's not going to change anything. So certain steps can happen before or after each other, and they don't affect the overall goal. They still need to happen, but the order doesn't specifically matter. So proofs are very similar to that. We can do things kind of in an order that we feel like doing them in, but we need to make sure that they're important to the proof, to getting from one end to the other, And we also need to make sure that something didn't need to happen before that in order to make that true. So sorry, I went off on a little tangent there. So now we have our two pieces equal to each other. Now we can deal with this other equal to piece. So I want to be able to get just QR, and here I'm even going to write this over here. I have TR equals RU, plus RU equals QR plus RS. But remember, the prove, I want just RU and just QR. So I don't want this TR and this RS. I want some way to get rid of it. Well, if we remember, they equal each other. QR and RS equal each other. So I can substitute one for the other. It really doesn't matter which one I substitute. So I could, instead of TR, I could write RS. Or, instead of RS, I could write TR. Either one is correct. It truly doesn't matter which one I replace. But what I want to do is I want to replace one of them so that I can use that algebraic method of subtracting it away. So I'm going to go over here and I'm going to write, I'll go ahead and replace TR. So RS plus, not equals, plus RU equals QR plus RS. And the reason for that is substitution again. I'm just substituting RS for TR. I know that they equal each other. So now I can subtract RS away, just like we did on that last one, and all I'm left with is this prove, which actually, if I remember, I can go up here and I can click prove. I don't need to necessarily type it all in, and I can just go down here and go to the addition subtraction properties. I subtracted it away and validate. And your proof is complete. Happy day. So these ones, yes, they're a little bit more time consuming. We have to go through step by step, but it's all about thinking through the problem. How do I get from where I started to where I want to end? And then there's a lot more of these properties that we have to just know and understand. All right, so that was section 3. I will see you in section 4.